Good afternoon. Welcome to Migrating to Modules, the sequel to Modules in One Lesson. I guess I lied. It wasn't really one lesson. Well, it was an introductory lesson, but there it is. So how many people saw that session this morning? Okay, good. That'll help a bit, but I'll try to make this relatively independent. So this is another live coding session. I will make mistakes. Please shout them out if you think you can help. Questions of clarification are welcome during the main part, but deeper questions, let's try and hold those for the end, please. So what we're going to do here is look at a little application, a slightly bigger application than we looked at this morning. I've got JDK9 here, build 181, the GA version. We're going to take this little application. We're going to do two things. First, we're going to modularize it from the top down. Now, this application uses some popular but as yet unmodularized libraries, and we'll show how you can modularize a little app even before its dependencies have been modularized by their maintainers. Then we'll do the opposite thing. We'll go back to just having a regular class path application, and we'll modularize its dependencies. We'll pretend that we're the maintainers of these libraries. We'll modularize those, and we'll show how that works with the class path application. Then finally, at the end, we'll wind up with an actual fully modularized application. So, first things first. Rather than doing a boring old hello world, I thought I'd do something a little bit richer here. So I've got a file here of tweets in JSON format. You know, the XML of the 21st century. It's well, maybe a little more readable than XML. I'm not sure. So let's write a little app to display these in a more readable format. Well, we don't have to write it because I've already got it. org.tweetsum is the name of the app. It's got a main class. It's got two classes, unlike this morning's app. It got two classes. Let's take a look. Got a main class. It uses the Jackson XML. The Jackson JSON data binding library. You know, this is very simple. It creates an object mapper, makes a list of tweets, reading from system input, and then displays those tweets on standard output. And it uses this tweet class nearby. Little poja represents a tweet. It's using a SQL timestamp to represent the time. Using more Jackson stuff, we've got two annotated properties, a timestamp property, and the text property, which is just the text. All right, so that's pretty simple. Let's compile it and just show that it works before we attempt to change anything. In my lib directory, I've got the three Jackson jar files that I need. These are a slightly old version, but for these purposes, it doesn't really matter. Let's compile these. So what do we do? Java C -d classes class path. Let's see, after lib Jackson and well, let's start with core data bind lib Jackson annotations, and I'll just find everything I can and compile it. All right. Now let's make a jar file. And this is all very mundane. That is one of the loudest phone buzzers I've ever heard. Okay, and just to show that everything works, we can run it with that long, awful class path. Add my tweetsum guy, and what do we get? There we go. Tweets in a more readable format. Okay, woohoo. That's our starting point. So let's start by modularizing tweetsum. Here's the structure again, just to remind you what we're going to do is we're going to put a module declaration in the org.tweetsum directory. Module org.tweetsum. And now in a module, I need to declare what my module exports and what it requires. So this is a little application module. It doesn't export any APIs, so there aren't going to be any exports in it, right? But code in this module uses those three Jackson libraries. But what do I do? What do I do here? What I'd like to write is Jackson core, or com.faster.xml something, or but I don't actually have a Jackson core module. All I've got is a Jackson core jar file, and the same for the other Jackson libraries that are sitting there. So I mean, the things that in plain old jar files, they aren't modules, right? There's no module info in those. Now, I could go and edit those jar files and sort of force module info.class files into them, but that's probably not a good idea. It's generally never a good idea to mess with jar files provided by someone else. So the answer here is a feature in Jigsaw called automatic modules. So an automatic module is a way of taking a relatively sane jar file or set of relatively sane jar files and just treating them as modules, even though they don't have module info.class files in them. This is for top-down migration. It requires a couple of things of all those jar files. For example, they can't have conflicting packages. So if they have conflicting packages, you have to leave them on the class path. But Jackson is a well-engineered system, and there aren't conflicting packages, so that's not a problem. With automatic modules, the name of the module is taken from the name of the jar file, which is probably not the actual name of the actual name that that module will be given by its maintainer when its maintainer gets around to it. So this is why in top-down migration, we recommend that if you're using things as automatic modules, don't publish your own module, because you'll be declaring dependencies on something that might have a different name when its maintainer actually modularizes it. Anyway, but for top-down migration, this is a pretty good heuristic if you're just doing modules on your own for now until your dependencies have caught up. So at this point, I can write requires jackson.core, requires jackson.databind, requires Jackson annotation. Is it annotation or annotations? Annotations. And that should work, right? That is a really loud phone buzzer. It's going to be on the recording. So there's another way to figure out what things your existing code might need, and that's with the JDEPS tool that I mentioned at the keynote yesterday. So JDEPS is kind of a Swiss Army knife of static analysis for code that runs on top of the JDK. Just as a side note, very important one is the JDK internals option. You run with this option, it will look at an existing jar file or set of jar files and see if there are any uses of JDK internals. And happily, there are no uses of JDK internal APIs in our little application. Okay, so that's good. You can also use this -s option. We'll show you some more. That not found is because I need to tell it where to find the rest of the dependencies here. So let me copy that. So JDEPS will look at all of this stuff. Now we see that JDEPS is saying that there's code in org tweetsum jar that it wants to use things in these Jackson jar files, and that'll probably work as if you treat them as automatic modules. It's also telling us, it noticed what we forgot, that org tweetsum jar is using that timestamp class in the Java SQL module. So we forgot that. We need to add that here. requires java.sql, otherwise it won't compile. It certainly won't run. All right, so we've got our modularized application here. Let's remove that and compile it. We're going to compile first into a mods directory, the modular form of classes directory. Module path lib, we tell the compiler module source path. Source. Java-C has a deep understanding of the structure of a source tree. So you can structure a source tree as with per module directories and just tell it, go compile the tweetsum module, and it'll just grab the whole thing. You don't have to list individual Java source files by yourself. Whoops, module, you gotta type it right, Mark. There we go. And now in our mods directory, we've got this is an exploded module. We can Java P. There's our compiled module info. Has exactly what we expect in it. Okay, let's create a jar file for that. Here we're going to take it from there, and we're going to put it in the lib directory. And along the way, let's add a main class. When you package up a modular jar, or even a non-modular jar for that matter, you can specify the main class, the entry point for it, and we're just going to say, as a convenience, that the main class is org.tweetsum.main. Yep, that should work. There we go. We have a modular tweetsum jar file, and now we can run it. We're going to run it with the module path is lib. So remember, in lib we now have our Jackson annotation jar files unchanged, just downloaded from Maven Central, and the tweetsum jar file that we just built. We'll say Java module path lib and ask it to run a tweetsum application, and we get an exception. Oh no, what happened? What happened was we missed something when we modularized. So let's take a look at the exception. Java lang reflect inaccessible object exception, unable to make org tweetsum tweet accessible. Module org tweetsum does not open org tweetsum to module jackson.databind. So basically what's going on here, the Jackson data binding library, like most data binding libraries, is using reflection to dig in to the Pojo class that it's trying to support. And that's not working. That's not working because the module declaration for the tweetsum module doesn't make it available. It's it's an internal package. But in this case, it's not quite totally internal because, well, as the author of the tweetsum module, I know I'm using Jackson data binding. It's okay for Jackson data binding to access the guts of my internal class. I actually want it to do that. Now what I could do is exports, I could try exports org.tweetsum. Try to export that package. That might work, but I'm sorry, actually that won't work. I misspoke. So let's see what happens. I'm gonna use a little command I cooked up called JJ to save some time. So let's recompile and repackage. Our module and try to run it again. Oh, silly me. Sorry. Thank you. Live coding is always a bit of a high-wire act. All right, let's try this again, and what's going to happen? The same thing happens. And the reason the same thing happens is that when you export a package, that does not make all of its non-public members available for deep reflection. It makes them available as an API. So other code can use the exported API of that package. What we really need to do is what that error message originally suggested, which is something other than export. There's this other way to expose a package, and that's called opens. So opens is designed exactly for this kind of use case. You have a package, it's got some classes in it. You don't intend that package to be an API. You don't want other code and other modules or elsewhere to compile against it. But you do want to allow something like a data binding library to use deep reflection on it. So basically, you can think of it at a high level. It's export not at compile time, only at runtime, and at runtime allow reflection on non-public members of the types of even non-public types. Did you have a quick question?
Can you open that only for Jackson?
Indeed, I can. If I want to be a little bit paranoid, I can say opens org.tweetsum to jackson.databind. This is called a qualified open. That you can also do qualified exports if you want to export something just to one other module or set of modules to have, an even higher level of integrity in your system. Okay, so let's JJ that guy up again. And now it works. Okay, so now we've got the modular application. It's using the Jackson libraries as automatic modules, and we're done with the first step. Okay, to get a little bit of a closer look, let's make a little JRE so we can see what's going on. I'm just going to run JLink real quick here. So I list the modules in this JRE. It's got just the modules that this application needs, and we can run it. Don't need all those modules in the JDK, all 70 odd of them. There's some good options in the Java launcher now for diagnosing the module system. You can do show module resolution, and it will display information as the resolver works to figure out what modules you need. So it starts with the root module in this case for the resolution process is the tweetsum module. It sees tweetsum requires SQL, requires Jackson data bind. It shows you the URLs at which it finds those. In the case of the SQL module, that's the JRT URL. That's for the internal NIO virtual file system in which you can find all of the classes inside the JDK. Finds annotations, finds core down here, figures out that SQL, oh yeah, that needs logging, and SQL requires XML, binds up some services, and then goes. So that's what's going on there. That is really a loud phone buzzer. I'm just sorry. Sorry? It's a door? Really? Wow. Okay. So automatic modules they're good for modularizing applications, as I said, top down, but they're not recommended for use in published libraries. Now there is yet another kind of intermediate step here. Modularizing existing libraries can sometimes take a fair bit of work in order to enable the maintainers of existing libraries to kind of set a stake in the ground, declare this part of the frontier as the module name they intend to use. When they get around to doing proper modularization, we've provided an interim step. You can use a new entry in the jar file manifest called automatic module name. If that entry is there and your jar file is not an actual module, then the module system will read that manifest attribute and use that as the name of the automatic module that will be created for your jar file. So it's a kind of an intermediate waypoint along the way to modularization. And I've been pleased to see a number of popular libraries where their maintainers have already declared automatic module names in advance of doing the work to actually figure out what should be in their module declarations and publishing them as actual modules. So that's great. Okay, let's rewind here. I'm going to clean up everything. Let me leave that for the moment. And through the wonders of Mercurial, I'm going to now enter an alternate universe in which I pretend to be one of the maintainers of the Jackson libraries. So let's recompile the TweetSum application as a regular old, class path application. That should do the trick. Okay. There we go, a non-modular jar file, so that's how we're gonna operate with that. Actually, I forgot, let's do just for amusement. Okay, that'll make things a little easier later on. Okay, so we imagine we are the maintainers of the Jackson libraries. We've got these source trees here for Jackson itself, com.faster XML, Jackson core, blah, 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 all these wonderful class files, Java source files, benefit license, and so forth. So this could be a biggish project. There's a lot of stuff here. How do we go about it? So the directory structure actually tells us a fair amount. You can kind of guess, well, annotations is probably, each one of these jar files is, it kind of looks like a bit of a module already, but how do we figure out what they export, what they require, what they need? And again, we have JDEPS comes to the rescue. So we run JDEPS on those Jackson jar files we have still in the lib directory, and JDEPS does that same static analysis that I showed before and shows what the relationships are. So all these jar files need, they need the base module. Well, everybody needs the base module. Databind uses SQL and XML, and also uses the other two Jackson jar files. So JDEPS has yet another option. Remember, I did say Swiss Army knife. JDEPS can generate module info, draft module info.java files for you. So I'll do generate module info into a directory called, into my source directory. This is a little bit scary. I'm using a tool and it's going to write into my source tree. Okay, that's all right. It'll be okay. Let's do lib Jackson core first. Okay, so we have a module info. It's always a good idea to look at what it did here. And we've got Jackson core, exports a bunch of packages, okay, and what's this? This says provides. What is that all about? So it turns out the module system knows about services. So services are a fundamental tool in the module system. They're especially useful for breaking cyclic dependencies. When you might think that two modules each need to depend on the other, or through some more complicated kind of cyclic relationship, the answer more often than not will be refactor one of them as a service that the other one looks up, and that will help you break that cycle. We have used services throughout the JDK itself to break many cycles along the way here. Okay. So I can actually generate module infos for all of these at once. It does all three. So that core one looks pretty good. I probably ought to change the module name to com.faster.xml. whatever, but I'll just leave that here for now for simplicity. Let's look at the annotations module info, check that out. Okay, it's just going to export one package. That looks all right. Data bind, module info. So a couple of things here. One is we see it put requires in here, and in particular, it put in these requires transitive declarations. So when one module requires another, that just means that the first module will be able to access the exported or open packages of that other module. If some third module requires the first one, it's not going to see. Sorry, the second one. Sorry if this is getting to be a if module A requires B, and B exports some packages, then module A can use the exported packages in B. If some third module X requires A, it will see the exported packages of A, but it won't necessarily. It won't see the exported packages of B unless X also requires B. But if A uses X in its own APIs, then as a convenience to users like module X, it should do a requires transitive, and it provides a convenience. Basically, it means any module that requires Jackson.databind will implicitly also require Jackson annotations and Jackson core and Java SQL and Java XML. And JDEPS has a heuristic for figuring this out by analyzing the type signatures of public classes and interfaces. Okay, so those are the requires that it generated. And it also generated a bunch of exports based on the package that exists. Now, JDEPS has no way of figuring out what might be internal and what not. There are various conventions people have used over the years for marking things internal, but in this case, we can pretty easily see there are some impl packages. So we're just going to comment those out, or heck, let's just delete them, because chances are pretty good that that's not meant to be part of the Jackson API, so we don't need them. And there's another service here, then JDEPS figured that out by looking at the services directory in metainf. Okay, so we've done all that. Let's compile, and we're going to make a new directory, mlib, where we're going to put the modular versions of the Jackson libraries. Jackson.core. User overrides a deprecated API. Oh no, that's a problem for another day. Annotations and data bind. Bigger module, takes a little longer to compile. Ooh, more deprecated APIs. Okay, so now in mlib, we've got these modular jar files. We can take a look. Data bind, for example. Ask the jar tool to describe it, and there's the content of the module declaration in binary form. Exports the stuff we expected, requires the things we expected, and we're good to go. Okay, so we've got modularized Jackson, we've got our unmodularized TweetSum application, and let's now try and run them together. So Java module path mlib, where we put the Jackson modules, class path, well, let me just use the TweetSum jar file, tweets.json. Oh yeah. There we go. Okay, something went wrong. What went wrong? Well, what went wrong was I'm running, when you run a class path application, which is what TweetSum is, the module system doesn't know what non-JDK modules it needs. So if it needs modules outside of the JDK, you need to add them manually. So what we'll do is we'll add Jackson core Jackson data bind and Jackson annotations, and that works. So it's a little awkward, but at least this is possible. You can have code on the class path, you can have some other code in modules on the module path, and they work peacefully together, but you do have to tell the module system at startup what modules to put in there.
What is module path does do? I can have module path and add modules. Are they
So the module path is where you put artifacts that define modules. The that's what we call, the module path is where you put your modular jar files, or modular jar files that you want to use, rather than on the class path. The module system will look on the module path for modules that it can tell it needs defined. But when you're just running code on the class path, it has no way of detecting, oh, this unmodularized code on the class path needs some module on the module path. So add modules tells the resolver, okay, before you start this code on the class path, load these additional modules too, plus whatever modules they depend upon. So that's why you need to both use the module path option to say where they are, and then the add modules option to say which ones you know are necessary for the code on the class path. If you're in a rush or you just want to be lazy, there are some shortcuts here. For example, you can say all-module path, and it'll just go find everything that's on the module path. That's probably not what you want, but it can be a useful step if you want to just debug something. Okay, so this has been bottom-up migration. Now let's do kind of the obvious last step and modularize everything. We'll go back to the tweet sum. Module info, which I happily left around here. We'll just write it back out and recompile tweet sum. This time it'll wind up as a modular jar file. Whoops. Right, when I compile it now, I need to tell the compiler, module path mlib, where my actual modules are. I'm actually going to put tweet sum into mlib as well. So here I have in mlib all my nice modules, and I can run where'd it go? Oh, let me just make that again. Fully modular tweet sum applications. So now everything is a module. We've taken both the top down and bottom up. Everything's a module. Life is sweet. And here we can show module resolution and see everything being resolved. The root is the tweet sum module, as we saw with top-down migration. It loads all of these other proper modules now. They're not automatic modules anymore, and it finishes up by printing its output. So that's it. As far as demonstrating this, migrating to modules does take some work. If you have a large existing system, frankly, it might not be worth the effort. So think carefully before you start off a project to modularize a lot of existing code. If you have a large system that's like a whole bunch of Maven projects, and it works well, and it's kind of in maintenance mode, there's a good chance it's not worth going to the trouble of modularizing it. On the other hand, if it's actively maintained and evolving, and you plan to take it forward, then it could be worth the effort. But the good news is Jigsaw provides ways to do both top-down and bottom-up migration. The concept of migration it's maybe not one of Java's key core values, but it definitely ranks up there. It's something we've taken seriously over the years. It affected, for example, the design of generics in Java 5, we took some pains to make sure that code that adapted to generic types could work well with code that had not yet been adapted to generic types. Now, by now, most code does use generic types, but there's still some that doesn't, and they all work fine together. So we've taken a similar approach in Jigsaw, where code that's in modules and code that's not in modules can coexist and relate to each other and interoperate. So that is the concept of migration compatibility. Okay, we've got a few minutes left for questions, if there are any. Yeah, okay, please wait for the microphone. This is being recorded. If you don't wait for the microphone, then it won't be on the recording.
Okay. At the beginning you had the Jackson jars, and then you opened up the module and did requires jackson.core. Where did that name come from? Was that the automatic? Pardon? Was that an automatic name, or was that the package name?
So when you take a jar file that's not modular and put it on the module path, then its module name is synthesized from the file name. In a way, it's a gross hack, but what else can we do? So the name of the name of the module, the automatic module defined by Jackson-core-2.6.jar is jackson.core, and that's all it is. It's nothing fancy. Now, if the maintainer of that library puts in an automatic module name entry in the jar file's manifest, then the name of the automatic module will be taken from that manifest entry. But in the long term, we hope that the libraries like Jackson will actually be full modules. I heard recently the Jackson maintainers actually did put in the automatic module names, so they've taken kind of the first step down the path to modularizing something.
Are there any of the, I'd say at least 3 most common IDEs that support many of the commands and tools that you showed here?
I had Eugene Petrenko from IntelliJ in the keynote yesterday demonstrated IntelliJ IDEA. It can show module graphs, and it has a deep understanding of how module declarations work, how they relate to each other. If you forgot to say require somewhere, it will suggest insert this one, and so forth. So that's pretty slick. Eclipse has some support, but I'm not sure how deep it is right now. I do know that they're actively working on it, and I believe the same is true of NetBeans.
NetBeans?
I believe the same. I know NetBeans contributors are working on it, but I don't know the status. They haven't released a 9 version yet.
Yeah, I guess they haven't released anything at Apache right now.
Yeah.
Yeah, there's a NetBeans is a 9 preview at the moment.
Yeah, there is a 9 preview, but it's not final.
And I think the Eclipse version, the supports module, comes out in 2 weeks' time, or.
Well, yeah, with Eclipse, there's a well-known page on the Eclipse website that tells you how to use it with 9, and their formal release will be in a few weeks. Any other questions? Gentleman in the back there.
Hi. Every current application written in Java 8 will run on a Java 9 virtual machine?
So the quickest answer is refer you to the video of the keynote from yesterday. The slightly more verbose answer is, if you have an existing code that only uses Java SE8 APIs and does not depend on JDK internal APIs or other internal aspects of the JDK, it will probably work on JDK 9 without change.
Thank you.
I need to show you this slide. I work at Oracle.
Hi. What's the impact on build tools such as Maven and Gradle?
Well, Robert Schulte is sitting right here. He could certainly speak. He knows that. I know the answer too, but there is impact. I'm happy to report that we've worked closely with Robert, and Maven has decent support for modules already.
Yes.
Say a little more.
So what we did is we tested with Maven 3.0, and that just works fine. Probably even earlier versions of Maven also run fine on Java 9. But we just started with 3.0. If there are issues, they're often related to the plugins. For instance, there was this change to the version scheme, where it was 1 dot and then the version, and it has changed to 9. And what all these tools were doing, they were making an array, just splitting it on a dot and taking the second element. When it's just 9, they're getting an array out of bound index exception. So these are already fixed, and I think most of the plugins right now are Java 9 ready. So.
Right, but Maven also will build modular jar files too now. So it's it's not just that it works the way it always did on 9. It actually understands what modules are, and you can have a module info and do all that stuff.
Can I add?
Do it.
Just one thing to add: you don't have to change your folder structure. So, I think most of the examples you see that you add the module name in the source. You don't need that for Maven projects. Just keep the source main Java, put your module info there, and it will work.
Right. And that's because pretty much a module is modules in Maven projects are the same thing. There are no when we're showing things on the command line, if we need to talk about multiple modules, then we need to show the module each module have its own directory in the source path or the exploded modules. But that's just an artifact, really.
One other thing is you showed JDEPs in a couple of the slides. Robert has a plugin that Maven projects can run as well.
Right. Good point.
I just wanted to add that we have a Maven BOF tonight, so if anyone is interested in more details, we can talk more in detail then.
Excellent.
Any more questions?
Any other questions? Just a few minutes. Over there?
Is there any mechanism to versioning modules?
No. That's most frequently asked question, either number 1 or number 2. It competes with why didn't you just use OSGI? No. So in this design, we took an approach. It was not our original approach. We arrived at this after a long time. An approach where modules and the artifacts that define them are separate concepts. So a module is kind of a higher level abstraction. They're embedded in the language. They're known to the virtual machine. They don't have version numbers in that environment. Think a module is as fundamental as a class or an interface. We don't put versions on those, but we do put versions on the things that contain them. So it makes perfect sense to have versions on a modular jar file, but we basically leave it to build tools like Maven and Gradle and Ant, whatever, to worry about version conflicts. The module system will detect conflicts. If you have 2 modular jar files in the same directory on the module path that define modules of the same name, the module system will just stop and say, it doesn't know how to make this choice, so you have to remove one of them or fix the problem. Modules do have, compiled modules can have module information in them. If I list modules, you see this @9. That 9 is inserted by the build system into the module info.class files, but it's just there as documentation. So that version string is not really interpreted. It's just carried through for diagnosis. So if you're trying to diagnose something wrong in a large system, you can see which versions of modules were resolved, but the resolver doesn't actually pay attention to those version strings. As I said, it is a little bit of a counterintuitive approach, which is why people naturally ask about it a lot. But that's the answer, and so far this seems to be working fairly well. All right, time for maybe one more. Okay, well, thank you very much. Go forth and modularize.